IDE, and I'll create one class here, CLAWS class, and I'll give it polymorphism. Okay, so let's just say I have created interface. I have to create class. This is class. So let's say I have created one method public, and I'll give a static void get name. Okay, that's why so let's print the name. Same, I am doing public, and I'm giving string get name, return okay. So we are talking about overloading. When we talk about overloading, so overloading, when does it happens? When we have the same method, this method signature is same, this we have to check, and the argument changes. So let me give argument here. I will give string str. So this is method overloading. Whenever we have the same name, method name, and different parameters, it can have different return type, it does not matter, but the main concept, the very important thing is to remember that the name should be same and the argument should be different and their order should be different. Let's say I have one more method public, or let's say it is not public, it is private. It does not matter, the access is where these are the access modifiers, does not matter in overloading. This is the return type, it does not matter. What matters, the name and the arguments, this matters the most. This thing only define that whether it is overloading or not. So I'll give void get name, method name is same, and I'll give int a and int a double b here as an argument, and I'm not returning anything. That's why. So this is int and double. Okay, I'll create one more. Let's not create int and double. Let's create int and double. That's not an issue. Let's do this double and int. Okay, so this is overloading. Why do we say overloading? We have the same name, but the arguments are changing. We do not have any argument. We have argument 1, we have 2 argument, we have 2 argument, but the order is different. So this is overloading when it happens within the same class. I have created within the same class, and it calls overloading. And let's understand the overriding. So overriding we have already done. Not this. Let me create this. This is over. No. Let me create one example for overriding. C class overriding. So overriding happens between 2 class. So let me give it test1, not overriding. And other class I'm creating test2, CLA test2. So I have created one method here, public string get length. gth return int, we can do here return. Okay, now I will implement this. I'll extend, because overriding only happens when we have inheritance in picture. So we are inheriting the test one here. So test one is inherited. Now it will ask to implement this method. It will override here. It is not doing that. Public int, public class this, public class this, we have extend this. So it will look like this. We'll extend this and we'll have @override here. Okay, now what happens in overriding? In overriding, the everything remains same. Int return time will remain same, method name remains same, method signature remains same, argument remains same, everything remains same. We can change this, but to widen the scope. For example, if it is protected, then we can keep it protected or public, because public is more widen, it is more flexible than protected. We can do that. Other than that, we cannot do that. What we do, when do we use it? To change the implementation. So we have changed the implementation. In this part we are returning 1, in this part we are returning what? We are returning 2. So this is the overriding. When do we do overriding? When we have to change the implementation, right? So this is overriding, this is overloading. Override in overloading, we also say it compile time, because this happens, this works on compile time, and this overriding happens on only in runtime. So this is also called runtime polymorphism. Okay, runtime polymorphism. Now this is compile time polymorphism. Okay, so this is polymorphism, and we also there is one more name to this, static binding, and this is dynamic binding. Why static, why dynamic? Because it happens on runtime. That is why dynamic, and because it happens initially when we are writing the code, this is called static binding. So this is it in polymorphism. Let's move on to the next topic. Next topic is abstraction. What is abstraction? Abstraction is the hiding of implementation details. Whenever we create any abstraction, we hide the implementation. We write the method, we do not give the implementation. So let's abstraction. Abstraction is hiding the implementation details and showing only the functionality to the user. Only the functionality to the user, right? And how do we achieve this abstraction? We achieve it through abstract class and interface. We achieve it through abstract and interface, abstract classes and interfaces. The spelling is wrong here. Okay, now how do we do that? Let's write an example and understand that. And I'll give class CLA class. I'll give abstract class, and the name is shape. Okay, We have abstract class here. Now I'll give some parameters here. Public, some method I'll define. Public abstract double area and public abstract double perimeter. Okay, this is also method. So we have written incomplete method. These are called incomplete method which do not have body. What is body? If we write like this is body. But if I write like this is without body. It is abstract method, which is incomplete method. Implementation is hidden here. Implementation is hidden. Now I can give you one shared functionality also, but not right now. Let's create one more class, CLA circle, and I will give circle extends shape. Okay, now it will have all the methods from here. See, what are you seeing here? Add unimplemented method. So the implementation will do here. Now we have implementation here. Now we'll add few more things here. Public double radius and public, and the constructor for this public circle double radius, radius radius. This is the constructor. So this dot radius equal to radius. Okay, now we have the implementation. Now I'll write the method here. I'll do in this all only. What would be the area? Area would be, I'll do math dot pi into radius pi r square. You must have remembered the formula. Now here parameter, what would be the parameter? It's 2 pi r. So I'll do 2 into math dot pi into r radius. Okay, now I have two formulas. I have implemented the methods here. Okay, now I am going to create one more class, CLA. This class is rectangle. And I'm extending this class extends shape, and it will also have the same unimplemented method, but the formula would be different this time. I have to find out the area. What is the area of rectangular? It is length into breadth, so we have to create two parameters here. I'll give private double width and length. We can also do like this, like we have declared two variables in one go, width and length. Or okay, now next thing I have to create what? I have to create constructor. So let's create like this. using field and the width. So this has created me the constructor. Now I have to find out the area. What is the area? The formula for area is width into length. So width into length. Okay. Now what is the parameter for the rectangle? 2 into L into B, L plus B. That is what we have learned. So 2 into length into length plus breadth, length plus width. Okay. So you see here what we have done. We have used only single abstract class where we have this implementation hidden here, and we have implemented in two different classes. This gives us the flexibility. We can use the same single abstract class or interface. We can also make it interface to any number of classes, and we can change the formula, the implementation we can change, we can modify it every time, and this way it gives us flexibility and more modularity. It is easy to maintain. Okay, so this is it. This is what this is abstraction. Okay, now let's go to, should I run it or not? I think this is fine with you. If you want, I can run it also. Let's say in one method I can run it. Let's run it from here only. Okay, so let's create a class, new rectangle, and for rectangle what I'll give value 3 length and 2 breadth. Now I'll call the method so rectangle dot area, and for the same thing I'll call rectangle dot. Okay, now let's run it. You see, I have the area and I have the parameter. That's it. Okay, now let's move on to the second thing. Like, we have done abstraction, all 4 pillars are completed. Now let's go to some more parts. There are 2 keywords we have used here, this and I'll write here this and super keyword. So what is this keyword and what is super keyword, and why do we use it, and why it is important to us to understand? So let me, what happened? Okay, so what is this keyword? This keyword is used to refer to the current object instance, where whenever we use this, as you can see here, we have used this means current width would be given this width, whatever width we are giving 3, this width would be assigned to the current given. So it refers to the current object instance. It refers to the current object instance, right? And it differs, it is used to between instance variable from local variable. Variable from local variable, right? And it is used in the same class. It is used in the same class only. Understood? Now, what is super? So super is used whenever we are in overriding concept or whenever we are inheriting. So this refers to the immediate parent class. What is immediate parent class? Immediate parent class is the very near parent class. For example, for this rectangle, the immediate parent class is shape. So when this super is called, this super will be calling the shape. So this is what is about this super keyword. Okay. So this super keyword, what it does, it invokes, used to call the parent. It is used to call the parent class constructor, and it invokes the parent class methods. What it does, it is used to call the parent class constructor, and parent class methods. So the main difference is this only, that whenever we use this, it is in the same class, no inheritance, but super will be used for the different, like for the parent class, the immediate parent class it will be used, and the function for both is same, but for different purposes. It will be used in case of inheritance, and it will be used within the class, and both would be both super and this would be the very first statement. And we cannot, if we are writing super, so for example we have written super here, let's see, here I have written super, so let's try to give it here. It will not work because it says the constructor must be the first statement in a constructor, the constructor call. Okay, so that's why we say, and same goes with this keyword also, but both cannot be used at the same time, both can't be used at the same time, because both cannot be the first statement in the constructor same time. Okay, so this is about this and super keyword. So let's do one thing. Let's take one example for this. I'll create class CLA and what will I have? I'll have the name vehicle. Vehicle. And in this class we'll create some field. I'll have string type int speed, and I'll create constructor using field. It will create the constructor, and for now I'm removing this, and I am creating one method void display, and nothing in argument SYSO, and I'm displaying type plus @ plus speed in kilometer per hour. Okay, so this is the display method we have. Now create one more class, CLA class car. I'm creating, I'm extending the vehicle, extend vehicle. Okay, now it will ask to implement add constructor. I have added constructor. Now I'll add one more, this string brand, one more variable here. Okay, now after this I'll do one thing. I have speed, this type I have I'll do this brand, and I'll create. We can create constructor for whatever field we want to. So we are creating two constructor for this only, brand and speed. So brand is what? The car, whatever brand car it is. So I'll give car, and speed is the speed. Okay, what is this doing? Brand and speed. It will be calling the constructor of here, right? Type. So brand we have given, here. It will call the vehicle constructor. Now this dot brand we will write here. Okay, brand. Okay, just remove this. Now what we'll do, we'll use one more constructor, which is public car, and I'll give string brand here, and this dot. This I'll call this brand 120. What it will do, it will call the car string and int constructor. So where do you see string and int constructor? In this class only, right? And there is this method we have to override. @override. Okay, for display. Now in display, what we are doing, I will do this. I will call super dot display. So this will call parent SYSO, and I'll print brand here, brand. So the code is complete. Now let's understand. It will call immediate parent. So we have used super and this both. I have created this. With this keyword will call this one, and this will call super dot car speed. This will call the parent here. It will assign the value, and void display will be called from here. Okay, now let's okay. Main. Now let's create this only. I'll create this new car. This is the constructor. Add argument to car. Yes, car has some argument, so we'll add string. We'll add car new. Now let's start this new. Okay, I have to call the method only, so let me call the method new car and we have this brand. I'll give brand here. Porsche, and speed is 200. Okay, car dot display. Now you see this car dot display will call this method, and this method will go back to parent, and it will be here, and it will be printing car. Type is given here, okay, and brand is Porsche. So this is our this end, and brand is Porsche. Where from where it is coming? It is coming from here, okay. Super. What will I will give here? I will not give car here because I have hard coded. I will give brand only. So now it will give us proper Porsche, this one. So this is the super keyword. Now let's call this one new car, but it is not this. It is only brand. So we have to give the constructor to call this. Now I will call car1 dot display. Now let's call it. Now you see car1 dot display, what it is doing. Car1 dot display will call this method, and this method is calling what? Super display. And so after calling this one, it will go back to where it has printed this one, and it will go to here, this one, and this dot brand will call which method? It will call this, and this again will call this. So this is the use of this keyword and super keyword, okay. Now there is one more topic remaining, which is constructor. Let's understand that first. Constructors are simple. These are used to initialize the value, initialize the objects, like we are doing here. We are initializing here. We have initialized. This is the constructor. This is argument constructor. Two arguments are there. This is default constructor. When we do not give any value, that is default constructor. So that is we are going to do here. Let's explain first what is constructor. Okay, so default without argument, next we have parameterized with argument. Okay, copy constructor, takes an object of the same class. It takes the object of the same class and copies its state. Its state means its variable it copies. And constructor chaining. So what is constructor chaining? Calling the one constructor from another constructor. This is constructor calling one constructor from another is called chaining, constructor chaining. I do not have to write all that. Okay, so this is the constructor. So let me show you the constructors here. So this is parameterized, and this one is default. By default, program provides default constructor. Implicit user must be invoked by another constructor. So let me show you here. We have super use here, no? We cannot create constructor. Let me show in animals. By default, we already have the default constructor. Java gives us, we need not to create explicitly. So here I have given explicitly, otherwise it is not needed, but I have created to show us it is, it does not have any argument, it does not have any parameter, so it is default. Okay, so now this is done. Now what we have, the rules to create constructor. So constructors, rules to create constructors. First rule, constructor must have same name as that of class, as that of class. Okay, second, they do not have return type, do not have return type, and this and super, if we are using this, if we are using it, should be the first statement in constructor, and we cannot use both at the same time. Okay, so that is constructor. One more thing I have to tell you, constructors cannot be inherited because there is no need to inherit them. Constructors can be inherited, and it can't be abstract, static, and what, and final, and synchronized. Okay, that's, so this was about the OOPS, object oriented programming. We have learned about encapsulation, abstraction, polymorphism. Okay, thank you.